All right, so today is the last lesson for Trigo. For Trigo, we're going to wrap it up. Now, well, I'm talking about Year 9 Trigo, okay? Now, so the last topic that we're going to deal with is angle of elevation versus the angle of depression. So I'm going to show you what does the angle of elevation and the angle of depression mean, okay, in a bit. Okay, so if you can take out a notebook, put that as the title for today, and draw that diagram over there. So basically, two full solid lines, connecting B to A to C, and then put a dotted line across it, okay? All right? And that's what we call the horizontal. So that line is called horizontal. Okay, now I'll give you a few seconds to do it. All right, now once you're done, could you please let me know when you're done? All right, so draw two lines connecting B to A to C, and then dotted lines and across it. Okay? Yep. All right, so the purpose of us discussing about the angle of elevation and angle of depression today is so that we will be able to apply Trigo. We'll be able to solve some problems using trigonometry, including real life problems. Okay, so has anyone heard of the angle of elevation and the angle of depression? Anyone? Or you could guess.
No.
Mean? No. Okay.
Doesn't mean.
What's the thing to the left of H? What's the thing to the left of H? Oh, you mean that one? Okay. That's just an arrow pointing that line right there. Better?
I thought it was a sheep.
Okay. So that's just a little arrow indicating that the dotted lines is called the horizontal. Okay, all right, now, all done? All right, if you're done, just leave a comment on chat, or just verbally tell me, or just put an emoji or something, okay? So that I know. I can't hear you, Grace, I can't. Might need to turn on your microphone or something. Yeah, so yeah, instead of giving me a thumbs up, Alyssa was clapping her hands. All right, now, that's good. It's the same indication. That's good. All right, now, I'll get there so Dylan gives me a thumbs up. All right, so let's proceed. I believe that Denise and, she clapping something? Okay, now, so I believe that Denise is done as well. All right, now, so what is angle of elevation? What does the word elevation sound to you? What do you reckon?
Elevator.
Elevator. So elevator goes where?
Oh.
What's elevator for?
Down.
Down. Down.
Horizontal.
Yeah, down, but also before you go vertically.
Vertical.
Okay. Vertically. Okay, up and down, isn't it? So angle of elevation. The angle of elevation will be the angle, now well, it says the angle, so it must be the angle from the horizontal. Now horizontal can also be the ground, okay, be the ground, all right? So it's the angle between the ground and whatever object that is on top of that. So that is what we call the angle of elevation. Okay, the angle of elevation. So let's say, for example, okay, if I put my eyes right there, so that's my eyes, that's my eyebrows, my eyebrows. So if I put my eyes over there and I'm looking at the ground, right, my eye level is parallel to the ground. So when I look up, that's the angle of elevation. Okay, so when I look up, that's the angle of elevation. So let's say, for example, I'm looking right at you. So that's your horizontal, isn't it? Okay, that's horizontal. All right. So when I look up like that, that's the angle of elevation. Okay, so angle of elevation. For example, well, when John Norman's looking up at a skyscraper, okay, so that's the angle of elevation because you're elevating. All right, does that make sense? I get. So is it called angle of depression because it's down, and when you're depressed, you feel down? That's correct. So, well, let's say for example, when I don't know, when let's pick somebody who doesn't talk. Well, let's say when Alyssa feels down and sad, well, and she's depressed. So when you're depressed, you look up. No, you don't. You look down, right? Oh, I'm so depressed, so sad. So that means what? When you look down from the horizontal, right? Let's say the horizontal is right there, and you look down. That's the angle of depression. Okay. So that's the angle of depression. So that means the angle here is the angle of depression. Okay, so that's the angle of depression. All right. Yeah. So the angle of depression is the opposite. That's correct. Okay. Yeah. So here we go. So when you have your horizontal right there, it could be a ground, it could be a flat plane or a flat surface. Okay. Now when you look up, that is the angle of depression. I'm sorry, that's the angle of elevation. And when you look down, that's the angle of depression. Okay. So, do you know the two angles now? The angle of elevation and angle of depression. I'll show you an example. I don't know where my wooden ruler is gone. So let's say, for example, that's horizontal. Okay, so that's horizontal. Now, if I put my cursor there and I'm looking straight, that's horizontal, isn't it? Okay, so if that's horizontal, right? Now, when my head tilts up because I'm trying to look at something up there on the ceiling, what's up? All right, what's up there? That's the angle of elevation. All right, now back to horizontal again. Now, when I look down, that's the angle. What? That's the angle of depression. Okay, because I'm looking down. All right, so I hope that clears everything up. Oh my God, jeez. All right, now, so from there, I don't know whether you've noticed or not. Now, if I draw another one here, yeah, please draw another diagram. That'd be good. It does clear things up. So I'd like you to draw the exact same thing. I'm trying to make this perfect, or as good as possible. So then draw another dotted line across. Okay, so I don't know whether you have kind of seen it, but from that diagram over there, I see two right angle triangles. I see two right angle triangles. I don't know about you, but I see two right angle triangles. Do you know where they are? Do you know where they are? Hey?
I only see one.
Yep. Okay. So you only see one. How? Where?
At A.
At A? Uh-oh, that's not right angle. Not necessarily. It could be, but not necessarily. Okay. Now what do you reckon? Grace, what do you reckon? Denise said B and C. B and C. Oh yeah. B and C what? B and C. What B and C? Like that? What B and C? Come on, clear it up for me. Well, that's a good start. That's a good start. How would it look like? What's B and C? Come on, Grace. What do you reckon? Are you able to see two right angle triangles in there? Or not? Oh, she's probably talking, but I can't hear you. What about BAC?
Grace, we can't hear your mic.
Not really. What? Dylan, sorry, what was that?
Nothing.
Nothing? Norman, what do you reckon?
Is there like an invisible line?
Invisible line, that's correct. And where would be the invisible line be?
The horizontal line connecting to the top of B.
You mean
But
the
like
dot
on the right side though.
here?
Yeah, and draw it up to the top of B,
Like that.
but straight.
Oh, wow, thanks. Yeah, wow, thanks. Okay, straight. Yeah.
Is that it? Or am I wrong?
Is that it?
And then do the same for C.
Oh, do the same for C, okay. Reckon?
Is that it?
Honey, what do you reckon?
Draw a straight line.
Straight line where? Those are straight lines.
Like B to C,
C.
like straight down.
Like that?
Yeah.
Yep.
And there's two right angle triangles.
Yep. Honey's correct. And the beauty has just saved the beast. Well, but that was a good try. Okay? That was a good try. Now, so all you need to do is you draw a straight line across, and then you see two right angle triangles. Now, Norman, make a comeback. Where's the right angle?
I don't know.
No, what? No? What? No? No? Wait.
I don't know.
Yes, you do. Come on. Which one? Like the
Oh
right
yeah.
Where? Which one?
In the middle of the horizontal line.
Very good. That one there, isn't it?
Yeah.
Yep, good. All right, see, you got it. All right, now, so can you see there are two right angle triangles there? Yeah? So that means in the future, now you might be given any sort of diagrams, any sort of situation. Now you need to be able to form your own invisible line or lines, and whenever possible, if there's a right angle triangle, this is what you can do. Okay, so there's actually a right angle triangle, isn't it, over there? So there we go, that's your angle of elevation, and that is your angle of depression. Okay, that's your angle of depression. Right, so it goes back to Trigo. So let's say, for example, if we're having a look at this triangle here, so I'm just gonna grab that out and put it over here. Okay, it's actually a right angle triangle, and you have already learned Trigo. So it's just basic trigonometry again. All right, so what's your angle there? So let's say, for example, they're asking for the angle there, what's a theta? All right, if they give you a 3 centimeters there and a 4 centimeters there, and they ask you to find theta, you can absolutely find theta. Okay, and that is your angle of elevation because it's looking up, isn't it? Okay, if it's an angle of depression, so that one's that. If it's an angle of depression, you might get something like that. Okay, so you get an angle, what? Looking downwards, like that. Okay, so but it's still the same thing, it's just another reference angle, it's a theta. Okay, so using Trigo, when you have two sides related to one angle, all right, so you should be able to solve all kinds of problems as long as you've got either one side one angle or two sides. Okay, all right, does it make sense? Now, any questions before we proceed? Any questions? All good there? All good? All right, now I'm going to solve some questions with you. So they are word problems. So what I'm going to do is I'm going to type it on the screen, and then you copy it down in your notebook. Okay? So I'm going to give you only 2 or 3 examples. There are not too many, and we'll solve it together. So I'm gonna type it up on the screen, and then you jot it down. Once you have jot down the question, we'll solve it together. Okay? So that you kind of you get familiar with the problems. All right, now let's get started. All right, now, so your first example. All right, I'm gonna put this up. Give me 1 second right here, and where are you? Share screen and document. All right, let's do it together. So, are you able to see that? Is it big enough? Can you please let me know?
Yeah.
Is it big enough for you to see? Clear?
Yes.
Okay, let's get started. So, your first example. So, example 1, or you can put E.G1. Okay, so E.G1. It's up to you. Doesn't really matter. Now, let's do the first example. So, the first example is when you have a helicopter flying at a constant altitude of 91 meters, sights the middle of a landing pad at an angle of depression of 16 degrees. Okay, so I'm going to change that to 16 degrees. How far in meters must the helicopter travel to be directly over the, oh my god, to be directly over the, where is it? The landing spot at an altitude of 91 meters. Okay, now jot this down and we'll run through the question together. So a helicopter flying at a constant altitude of 91 meters. Okay? I'll give you a few seconds to jot it down. Now, because I can't see your chat right now, no, actually I can. All right, so there. All right, please let me know if you're done. You're done copying the question, and then we will analyze the question together. I'll give you a few seconds to do that. All done? Yes, no?
Yep.
Yep. Done, Dylan's done. Honey, what about you? Norman? Grace?
No.
Not done yet? Okay, keep going. Grace, for some reason I can't hear you. I don't know. Oh yeah, she said she's done. Excellent. Good job. Denise, Dion, you guys done or what? Yeah, Honey said she's done. That's good. Thanks for letting me know. Dion's not done yet. Denise, you done or what? I can't see Denise. Alyssa, what about you? Done? Yep, she says done. Donnie. Yep, that's what she said. Denise? Is Denise there? Where? I don't quite understand that word. All right, thanks, Norman. Done. All right, let's get started. Now let's analyze the question together. Okay, so a helicopter flying at a constant altitude of 91 meters. Pause. We'll start right there. Okay, so that's it. Look, so a constant altitude of 91 meters. So what I'd like you to do is this. I'd like you to visualize your problem. Now, when you visualize your problem, you turn the problem a complex problem into a simple problem. So you got a helicopter.